sky is wrong. Where the sun once hung, small and yellow and familiar, there now burns a swollen red furnace filling 1/3 of the heavens. Its light is the color of dying embers, and it is close, unbearably close. The oceans that cradled life for 4 billion years have long since boiled into vapor and bled away into space. This is Earth, and this is the last morning it will ever have. There is no one left to watch. The continents are bare rock, glowing dull orange, their surfaces slowly turning molten under a heat no living thing could survive. Mercury is already gone, swallowed whole. Venus follows, spiraling into the fire. And the red giant is still growing, its outer edge reaching hungrily outward, closing the distance to our world 1 million miles at a time. How did we get here? How does a steady, life-giving star become a monster that eats its own children? The answer was written into the sun at its birth, a countdown hidden in its core, ticking since before the first cell ever divided. 5 billion years from now, that countdown reaches 0. To understand the fire, we have to go back to the light, to a quiet star doing nothing more sinister than keeping us alive. Our sun was born from a collapsing cloud of gas and dust, one of countless stars ignited across the galaxy. At its heart, gravity crushed hydrogen atoms together with such violence that they fused into helium, releasing the energy that has warmed the Earth ever since. This is the sun's great balancing act. Gravity pulling inward, fusion pushing outward, the two locked in a standoff that has held for 4.5 billion years. But a standoff is not the same as peace. Something is quietly accumulating in the core, and one day it will break the balance. Every second, the sun converts 600 million tons of hydrogen into helium. The helium does not leave. It settles into the core like ash at the bottom of a fire, denser and heavier than the fuel around it. For now, the sun barely notices, but this ash is inert, unable to burn at current temperatures, and it is slowly choking the very reactions that keep the star alive. The question is not whether the fuel runs out. The question is what the sun does when it starts to. And here is the cruel twist that few expect. Long before the sun dies, it will grow brighter. It already has. The sun today shines nearly 30% more fiercely than it did when Earth was young. That trend will not stop, and its consequences arrive not in 5 billion years, but in a single billion. The end begins far sooner than the fire, and it begins with something as gentle as a star simply doing its job too well. 1 billion years from now, the sun's steady brightening crosses a fatal threshold. The extra heat drives a runaway greenhouse effect. Oceans evaporate faster than rain can return them, and water vapor, a potent heat-trapping gas, thickens the sky and traps still more warmth. The feedback loop accelerates. Rivers vanish, then seas, then the great ocean basins themselves, until Earth becomes a desert world wrapped in scalding steam. Life, if any remains, retreats to the last cold pockets near the poles. By 2 billion years, the oceans are gone entirely, boiled into a vapor that ultraviolet light splits apart, letting the hydrogen escape to space forever. Earth loses its water the way Venus did billions of years before. The planet that gave rise to whales and redwoods and human cities becomes a sterile rock, baked and silent. Yet the sun is still recognizably the sun, still yellow, still fusing hydrogen. The true transformation has not even begun. So what finally tips the sun over the edge? It comes down to that ash in the core, the helium that has been piling up for billions of years. When the hydrogen at the very center is exhausted, the fire there goes out. And a star with a dead core does something that seems impossible. To survive, it begins to swell. What follows is the most dramatic transformation any star like ours can undergo. With its core no longer burning, gravity wins the ancient standoff and the center collapses inward, growing hotter and denser than ever before. Around that shrinking core, a shell of fresh hydrogen ignites, burning fiercely. The star's outer layers, driven by this new fury, balloon outward. The sun begins to expand, cooling at its surface even as its total output soars. Its color shifts from yellow to orange to a deep, brooding red. Our star is becoming a red giant, and it will grow to monstrous size. The numbers defy imagination. The sun will swell to more than 200 times its current diameter, its surface reaching out past the orbit of Mercury, then Venus. Both inner planets are engulfed, dragged through the star's thin outer atmosphere until they spiral inward and vaporize. From 100 million miles away, Earth watches its siblings die. And then the question that has haunted astronomers for a century. Does the expanding sun reach Earth too, or does our world survive by a hair? There is a strange mercy in the physics. As the dying sun swells, it also sheds mass in a powerful stellar wind, blowing its outer material into space. A lighter sun grips its planets more weakly, so Earth's orbit drifts outward, retreating from the growing fire. For a moment it looks like escape, but the models suggest the reprieve is not enough. The red giant's surface and the drag of its outer atmosphere most likely reach Earth after all. Whether the sun's surface swallows Earth or merely grazes it, the outcome for our planet is the same. Long before contact, the heat radiating from that enormous red face melts Earth's crust into a global ocean of magma. The atmosphere, if any survives, is stripped away. Mountains that stood for billions of years flow like wax. Every trace of the world we knew, every fossil, every buried ruin, every atom that once was a living thing, is unmade in the glare. If Earth is engulfed, its end is swift. Plunging into the tenuous outer layers of the red giant, the planet meets friction and drag, spiraling inward over mere centuries, glowing, shedding material, until it dissolves completely into the body of the star. The iron of our core, the carbon of every forest that ever grew, becomes part of the sun itself. In a sense, the Earth returns to the fire it was born beside. There is a symmetry to it, dust to dust on a cosmic scale. But the sun's rampage as a red giant is not its final act. This monstrous phase is violent, but it is also brief by stellar standards, lasting perhaps 100 million years. The red giant is unstable, and it is running out of options. What comes next is quieter, stranger, and in its own way more beautiful than anything that came before. The dying sun has one last surprise left in it. Deep in the red giant, the collapsing core finally reaches a staggering 100 million degrees, hot enough to do what was impossible before: fuse the helium ash itself. In a moment astronomers call the helium flash, the dead center roars back to life, burning helium into carbon and oxygen. For a while the sun stabilizes, smaller and hotter, buying itself a last brief chapter of life. But helium is a poor, fast-burning fuel, and there is not much of it. Within 100 million years, this final fire also gutters out. Now the sun has no fuel left that it is massive enough to ignite. Unable to fuse carbon, the core falls silent for the last time. In its death throes, the star gently pushes off its entire outer envelope, layer after layer drifting away into space as a vast, glowing shell of gas. Lit from within by the exposed core, this shell blooms across light years, a delicate structure of green and crimson and gold. Astronomers call these objects planetary nebulae, and they are among the most beautiful things in the universe. Here is the twist buried in the tragedy. Those expanding clouds are not merely a headstone. They are seeds, enriched with the carbon, oxygen, and heavier elements forged in the sun's final agony. They drift out and mingle with the galaxy, feeding the birth of new stars and new worlds. Our sun's death is a scattering of the very atoms that make planets, and perhaps someday make life again. At the center of that fading nebula, one thing remains. The naked core of the sun, an object the size of Earth but half the mass of the original star, so dense that a single spoonful would weigh tons. This is a white dwarf. It has no fuel and no fire. It shines only with the leftover heat of its long life, a fading ember set adrift in the dark. For billions upon billions of years, this white dwarf will cool and dim, sliding down through white, then yellow, then a sullen red, until at last it emits no visible light at all. It becomes a black dwarf, a cold cinder the universe is not yet old enough to have produced even once. Around it, whatever charred fragments of the outer planets survived, Jupiter, Saturn, the icy moons, orbit a corpse in perpetual night. And so our star's story ends not with a scream but with a slow, patient fading into the cold. The sun that painted every sunrise, that grew every leaf, that watched over every love and every war in human history, becomes a dark diamond drifting silently through an emptying galaxy. It gave us 5 billion years of light. It asked for nothing. And when it is finally gone, the only proof it ever burned will be us, or whatever we became, carrying its atoms outward into the night.